Good day and welcome to our physics lesson for today. So for today, we're going to learn about forces and motion. We have some notes over here that we're going to use, and we're going to learn quite a few things about forces and motion. Okay, so what are the things we need to understand when we're talking about forces and motion? We need to understand. After this lesson, we're going to understand what is meant by balanced and unbalanced forces. We're going to describe the effects of balanced and unbalanced forces in motion. Okay, the definitions that we need to understand are forces. What are forces? Forces is a push and pull or twisting of something. Then we have a force of gravity. Force of gravity is the pull towards the center of the earth. And then we have this weird word called balance. Balanced means that all forces are equal in all directions, which means the item that we're looking at is not moving at all. Okay, so now we see that we have quite a few pictures over here. I'm going to explain to you what does it mean when forces are balanced and unbalanced, so we can see, because we're going to have to draw this in our exercises that we do during our lessons. Okay, so we have a rock over here. This rock is not moving at all. Force is in a stationary rock. Stationary means not moving or at rest. So when it's not moving, it only has two forces that are acting upon it. It is the upward force, and hold on, before we go to the upward force, we have a area that this thing is lying on, that this rock is lying on, right? Okay, so now we have the upward force called the contact force, right? And it's moving upwards. And then we have a downward force called gravitational pull or weight. We have learned that weight is the gravitational pull on our matter, or on an item's matter. Okay, so this is the ground, right? Okay, and the contact force is the same distance or the same length. Can you see this arrow is exactly the same length as this arrow over here? Okay, which means that this weight or this item has a balanced force, because both of the forces are the same. Where if this one is 10 newtons and this one is 10 newtons, this rock will be stable. It will not move, it will not roll away, it will not even wiggle its way out, because the forces are the same acting on this rock. But at this moment here, we now have a moving rock. So this rock is moving on this flat surface. Okay, we still have the contact force because it's still touching the earth, it's still touching the surface over here. So this is the contact force. Okay, contact. Okay, and we still have the weight. We still have the weight pulling it down to the ground. And you can see that both of these are balanced, right? Both of them same distance. But now we're going to add another kind of force on it. We have let's say the wind is blowing this rock. We have the wind. Wind pushing it down that side. Okay, and then we have the friction. Okay, so we have the friction. Let me see if I can write that a little bit better. So what does the friction do? The friction keeps or rubs against this side, right? While it is moving to keep it steady or to keep it from moving, right? But can you see that the wind force is higher or bigger or greater than the friction force? And that is why this rock is moving forward. Okay, so the wind is blowing from behind. The wind is blowing from behind here. Okay, and the wind force is greater or larger than the friction. And that causes this rock to roll until it stops. Okay, you see that the contact force and the weight is equal, but the wind and the friction is not equal. If the contact force was shorter, okay, then this rock would be floating, will be crushed. This rock would be crushed here. It will make a hole in the ground over here, which means the weight is heavier than the contact or greater than the contact. But if we have a large contact, okay, and a not so large weight, okay, this rock would be floating forward. Why? Because the contact force is heavier or greater than the weight. And that is what we mean that we need to have balanced forces. Okay. As soon as something is moving, it has unbalanced forces. Okay. So let's look at our next example. We have air resistance and terminal velocity. There's another word that we need to learn, terminal velocity, and air resistance again. So we all know by watching all the videos that we have, all the movies that we normally watch, all the action movies, when the guy jumps out of the plane, right? He falls very fast. He drops like a stone. But the moment that the parachute opens, he gets pushed up for a moment, and then after that, he still keeps on falling slowly and slowly downwards. Okay, but why does that happen? Why would that happen? So if he was a man alone, and the gravitational pull, so he was a man, and he flew out of a plane, or he jumped out of a plane. Okay, he jumped out of it, and now he's falling very, very, very fast. And say no more, this guy weighs about 60 kilograms. The earth would be pulling him down with 600 newtons, because that is his weight, right? Okay, so the earth is pulling him down with 600 newtons. And then, when he reaches a certain distance, he pulls the parachute. He still weighs 60 kilograms. Okay? And the earth is still pulling on him with 600 newtons. But the air resistance in this parachute is higher than the 600 newtons. Okay, which means this then pushes him up. And then until he reaches, so this is pushing him up, right? He's going upwards at this moment. He still weighs the same thing. He still has the same weight, but because of the air resistance gathering in that parachute over there, he pushes up. Now, when this guy reaches terminal velocity, now what means terminal velocity? Terminal velocity means that the force pushing him up and pulling him down would be equal to each other. So the force pushing him up 600 newtons and pulling him down 600 newtons would be equal, which means he would then, the speed that he goes down would decrease and become stable. It will be constant. Okay, so that is what terminal velocity means, is when the force pulling him up and the force pushing him down becomes equal and he reaches the space where his speed does not increase anymore. Okay, so when an object slows, the air resistance decreases, so the force becomes balanced again. So here at this moment, we have air resistance that is higher, air resistance that is higher than the weight pulling him down. Okay, it's higher than the weight pulling him down. That's why it's moving up. Here at terminal velocity, the air resistance is exactly the same as the weight pulling him down, which means he has reached terminal velocity. Air resistance. We're going to learn more about terminal velocity and how to calculate it a little bit later, maybe even grade 9. But at this moment, you just need to understand that when the air forces are equal, right, there's no speeding up. When the forces are not equal, when it's unbalanced, it speeds up into the direction where the force is the greatest. Okay, so this is it for our video. We are now going to do some little bit of work. Okay, I hope you guys understand how forces work. Let's recap what we have learned. We have learned what is meant by balanced and unbalanced forces, and we can describe the effects of balanced and unbalanced forces in motion. We know now what forces mean. We know what force of gravity means, and we know what balanced forces mean. Okay, so I hope you enjoyed the lesson. See you again later.